Hi everyone and welcome back to Maths and Physics with Mr. Simons. Today's lesson on grade 9 exponents, we're looking at exam questions and exponential equations, right? So let's look at the first problem. Right, so for equations, the question always says solve for x, meaning we want x on its own as a final answer and whatever it's equal to. So 4.2.1, they've given me 2 to the power x equals 16. 4.2.2, 3 to the power x plus 1 equal 3 to the power 4. There 3 to the power x equal 1 over 9. 3x cubed plus 1 equal 82. 5 to the power x equal 1. 9 to the power x equal 1 over 3. 8x plus 1 equal 1. 2 to the power x equal 1 over 32. So most of these sums work on the concept that we have to make the bases the same. So what do I mean? You see there I have base 3 and I have base 3. The bases are the same. I can drop the bases and then solve using the exponents. So they have base 2, I must be able to make that base 2. They have base 3, I must be able to make 9 base 3. Alright? They have x cubed, so this must become something to the power 3. They have base 5, so I must make 1 base 5. They are 9 and 3, I must make 9 base 3 because they have base 3. Base 8, so I can make 1 base 8, and there again base 2, and there base 2. So you can pause and attempt to solve it, see what you're doing wrong, so that you can use my corrections to help you practice till you can make no more errors, right? So, solve for x, so 2 to the power x equals 16. 16 can be written as 2 to the power 4. So 2 times 2 is 4, times another 2 gives me 8, times another 2 gives me 16. So therefore 16 is 2 to the power 4. Now you see they have highlighted in blue. So now my bases are the same. They both base 2, so I can drop them. Therefore x equal 4. So one mark there for making the bases the same and another mark for getting x equal to 4. 4.2.2, this one they've made it straightforward. They've made both bases 3 from the start. So therefore I can just say x plus 1 then equal the 4. If I take positive 1 across, it becomes a negative 1 on the other side. So 4 minus 1 then gives me 3. Right? 4.3.1, I have 3 to the power x equal 1 over 9. Right? 9 is the same as saying 3 times 3. So therefore I can write 9 as 3 squared. So 3 to the power x equal 1 over 3 squared. Now if I take 3 squared from the bottom where it's positive to the top, the sign changes. So it goes from positive 2 to negative 2. So now I have 3 to the power x equal 3 to the negative 2. Bases are the same. You see there both of them are base 3. Therefore I drop the exponents and I'm left with x equal negative 2. 4.3.2, I have 3 to the power x cubed plus 1 equal 82. So if I take plus 1 across, remember I have to solve for x. So I'm going to make sure I have x and x alone on the left hand side and everything else on the right hand side. So plus 1 first goes over. 82 minus 1 becomes 81. Right, then I have 3x cubed. To get rid of the 3, I'm going to divide by 3. So 3 divided by 3 gives me 1x cubed. 81 divided by 3 gives me 27. Right, now I want to solve for x. So now if that exponent is 3, I have to make this exponent 3. So x cubed equals 3 cubed. You should know 3 times 3 is 9. And 9 times 3 is 27. So 3 to the power 3 then gives me 27. Right, because the index there is the same 3 and 3, I can drop that and my answer is simply x equal to 3. Right, let's look at the next set of questions. So solve for x, we have 5 to the power x equal 1. Now this is a nice trick question and we always catch you out to this in exam. It's one of those we like because you'll always be like, but 1 and 5, how are they the same base? Remember the rule states anything to the power 0 will always equal 1. So if I have base 5, I can say base 5 to the power 0, which is 1. Give me 1, and from there now my bases are the same. You see there? Now I can solve and say x equal 0. 4.4.2 this side, I have 9 to the power x equal 1 over 3. We all know that 9 is 3 times 3, which can be written as 3 squared. X equal there, 3 to the power 1, if I take it up, would become 3 negative 1. Right? 2 times x gives me 2x equal minus 1. Right? The base 3's I've dropped because they are the same. From there, we always divide by whatever's in front of x, the coefficient of x. So 2 divided by 2 gives me 1x, but minus 1 divided by 2 gives me negative half. Right? 4.5.1, same as 4.4.1. 8x plus 1 equal 1. So we need to remember anything to the power 0 equal 1. So I have 8x plus 1, then 1 there would be 8 to the power 0. Right, the power 0 therefore becomes 1. Now my bases are both 8, so I can drop the bases and I'm left with x plus 1 equals 0. And if I take plus 1 over, x equal minus 1. Right, 4.5.2, similar to 4.4.2, we have 2 to the power x equal 1 over 32. Objective is we must make the bases the same. So if I have base 2 here, I must make that base 2. So 2 to the power x equal 1 over 2 to the power 5. So 32, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 gives me 32. So I multiply the 2 5 times to get to 32, therefore 2 to the power 5. Alright, if I take that up, it's positive at the bottom and it will become negative on top. So now it becomes 2 to the power x equal 2 to the negative 5. Therefore, bases are the same, I can drop them and x equal negative 5. Alright, so I hope you follow. I hope you enjoy the lesson. Continue practicing. I wish you nothing but the best. God bless. Bye.